As we discussed about the three methods of the preparation of the hydrogen, that is, one is the general method, which we have already discussed, that is the reaction of metal with the water, reaction of metals with dilute acids, and reaction of metal with bases, right? This you already know now. Now we are starting up with the second method of preparation, that is the industrial preparation. So that means how the hydrogen is prepared in the industries, right? So we have got two methods by which the hydrogen is prepared in the industries. That is, one is the most popular process, that is the Bosch process, and the other one is the electrolysis of some substances like water and you can say natural gas, brine solution, so on. So that means there are few methods by which you can, there are few substances actually on which you can carry out the electrolysis and they lead to the formation of hydrogen. So we'll be taking up these methods separately. So starting with the first method of the industrial preparation, that is the Bosch process, right? This is one of the most important process. Like if you'll get the question related to the industrial process, so that means there is an 80% of chance that you get the preparation, that is the Bosch process. That is very important and you will study in the higher standard as well, right? So just look at the board carefully. So by Bosch process, how the hydrogen is being prepared. So it is the first thing what we do is we take this thing coke. You know that coke is a powder form of coal, right? So what we do, we pass steam through it. And approximately the temperature is 1000 degrees Celsius, right? So what happens when this kind of thing is done, that is the steam is passed through the powder form of coal, that is the coke, it leads to the formation of CO plus H2. What is it? It is a water gas. What is it? It is a water gas, and this reaction is what it leads to the decrease in energy as well, right? So this is the first reaction which is carried out in the case of Bosch process, right? But we haven't got the main product which we were looking for, that is the hydrogen. So obviously some other things has to be done, some more reaction has to be performed. So what is that? In the second reaction, this water gas is passed through more steam. Means you can say the excess steam, and approximately the temperature is 450 degrees Celsius, and this reaction is catalyzed by a catalyst, that is Fe2O3, iron oxide, right? And we do have a promoter, catalytic promoter, and I think you are familiar with what is catalytic promoter. I told you catalyst is a substance which just increases the rate of reaction without undergoing any change in itself. It will be obtained as such as you will just put that substance, you will get in the same form and even the amount won't change. It will just increase the rate of the reaction. Now the question comes, what is the catalytic promoter? Promoter means we are using some other substance which will increase the efficiency of catalyst. That means it will just increase the activity of the catalyst. It will promote the catalyst so that it can make the reaction in an efficient way, or you can say it can act in an efficient manner, right? So what is that? That promoter used in this reaction is chromic oxide. So this promoter just you can say promote this catalyst, and catalyst just help in making the chemical reaction happen. And what happens in the presence of these two, this water gas react with the excess of steam, leading to the formation of carbon dioxide and hydrogen. So here is our main product which we wanted. That is why we were carrying out these reactions, that is the hydrogen, right? But the question is very important, what I am going to discuss now. So just listen to me. This hydrogen which we get is not an individual hydrogen gas that we can, you say that we will just extract or we'll use it. No, we are getting a mixture, right? So we have to separate this carbon dioxide from this mixture if we wish to get hydrogen gas in a pure form, right? So it do have carbon dioxide, and along with that it do have the unreacted carbon monoxide too. So we need to remove these carbon monoxide, unreacted carbon monoxide and the CO2 from the mixture if we wish to get the pure hydrogen, right? So we have obviously we have got the hydrogen, but it is not in a pure form. So how we are going to separate this carbon monoxide and the carbon dioxide? We'll be doing that separately again. A same compound cannot extract both of them. We'll be taking the different solutions or a different substance which will be extracting the CO2 and CO. So just let's look at the board that how these gases are going to be removed. For removing the carbon monoxide, if I want to, if we wish to remove the CO2 from the mixture, what we are going to do, we are going to pass this mixture from a solution of caustic potash, and you know that caustic potash is KOH, right? So we will just pass this mixture to the you can say a container which contains the caustic potash. So how this caustic potash is going to act? It will just react with the carbon dioxide, leading to the formation of potassium carbonate, and along with that the water will be formed. So that means CO2 is now removed. Now the second impurity which we wish to remove is carbon monoxide. That is, you can say, the some amount of carbon monoxide that left unreacted. So how this carbon monoxide is removed? Again, the mixture obtained by removing the CO2 is then passed through a mixture of ammonical cuprous chloride. This solution helps in removing this carbon monoxide. So what is the formula for this solution is? It is CuCl. So what we add? It is a solution obviously, so we are adding this carbon monoxide and obviously a solution, that means it do contain a water as well. So what is it is going to form? It is just going to form like this. So that means obviously the carbon monoxide is removed as well, and we are left with the pure hydrogen which we were looking for, or you can say for which we have carried out this Bosch process. So this is how we get to have the pure hydrogen as an industrial method of preparation for the formation of hydrogen, right? So this is how we get the hydrogen gas. So it is not only the one method, as I told you, there are few more substances which can be electrolyzed and we can get the hydrogen, right? And I think before we start, you are familiar with the electrolysis? Electrolysis is actually, before starting the electrolysis, you should know the tools which, or you can say the substances which are used in electrolysis, right? So just to make you more clear, I'll start with the basic electrolysis so that you should be familiar what actually the electrolysis is. Because once you will be familiar, you will be using this term in many standards and it means the same. So as I told you that once you start with any process, just you can say exaggerate that process so that it will increase your knowledge, right? So electrolysis, I'm just telling you the basic process. What is the electrolysis? In electrolysis, what we use an electrolytic cell, right? It is also called as voltameter, not voltmeter. Voltmeter is an instrument used to measure potential difference. I'm saying voltameter. It is another name for electrolytic cell. Right. So what do we have in it? We have the electrodes. Right, this. So what are the electrodes? They are actually the source of the current. That means we will be connecting these electrodes by means of wire to the cell or battery, and they will act as a source of current, you can say, for the solution, right? And the solution which we will be taking here up is an electrolyte. Now the question must be arising in your mind that electrolytic cell, okay, a name given to a specific type of cell in which electrolysis is done, right? Electrode, it is again a source of the current which is attached by the means of wires to a cell or a battery, right? The one which is attached to the positive terminal act as positive electrode, and the one which is attached to the negative electrode act as negative. Positive one is named as anode, you know that, and the negative one is named as cathode, right? Now the question comes, what is the electrolyte? Because the basic term, or you can say the basic substance which is very important in this reaction is an electrolyte. Electrolyte means, electro means electric current and light means lysis, means breakdown. So that substance is called as an electrolyte, which you can say it dissociate into ions when electric current is passed through it, right? For example, if I say the electrolyte I use here is AB, so it satisfies the definition of electrolyte only when the electric current is passed through it, it dissociates into its respective ions. If it do not dissociate into ions, that means it is a non-electrolyte. But for electrolysis, we need the electrolyte, that is must. So what is electrolyte? As any substance, right? It can be any substance. The only criteria which it has to be fulfilled, that when we pass the electric current through it, it should dissociate into ions, right? So this is so any substance which dissociates into ion can be taken as an electrolyte, and if it do not dissociate, it is said to be non-electrolyte. But for electrolysis, what is needed is an electrolyte, right? So this is the basic process, how the electrolysis occurs and this kind of thing. And what happens, like I'm just showing you that what happens after these ions are formed. They migrate to the oppositely charged electrode. Like the negative will go on the positive electrode, that is anode. Positive will go on the negative electrode, like that is cathode. And then there will be specific kind of reactions will be occurring on anode and cathode, that is with respect to the oxidation and reduction, right? So this is what is happening in the electrolysis, right? So now coming to the main method, why I told you this thing. The second method of industrial method of preparation of hydrogen is electrolysis. So which substances on electrolysis leads to the formation of H2? So those substances are water, this natural gas, brine solution, and moreover we have many more substances as well, right? So we'll just look at how the electrolysis of water yield the hydrogen. So what happens if you take an electrolyte as water? One more important thing, you know that distilled water is a poor conductor of electricity, right? So if you wish to obtain hydrogen by electrolysis from water, you cannot use distilled water. We need to make it impure by adding you can say a pinch of salt or a few drops of acid to it, or any other substance or any other impurity you can say. So if we add this substance, this water becomes a good conductor of electrolysis, and then only it dissociates into ion when electric current is passed through it. So when electric current is passed through it, it leads to the formation of H2 and O2. So this is how by the electrolysis, the same method that we'll be passing the current, it will dissociate into the ions. Oppositely charged ion will migrate to the oppositely charged poles, and there the oxidation and reduction will occur, and H2 will be evolved at a specific electrode and O2 will be evolved at the specific electrode. So this is how we get H2 by the electrolysis of water. Similarly, if we do the electrolysis of natural gas, so you should, I think you are familiar with the natural gas. The main component of natural gas is methane. What is methane? It is CH4. What is the formula for the methane? CH4. So what happens when we carry out the electrolysis? That means when the electric current is passed, when the electrolysis is done, it breaks up into CO plus H2. Again, a water gas. Right. So what happens to this water gas? This is again, you can say it again forms a method, that is it follows the this Bosch process, that is again the CO2 and H2, CO plus H2 mixture is passed through, that you can say the more amount of steam at 450 degrees Celsius in presence of Fe2O3 and the catalytic promoter chromium oxide, and then it again leads to the formation of CO2 and H2, and again we can separate the CO2 and CO from the mixture. You know that now, I've already explained to you in the Bosch process. So that means after the formation of water gas, you just need to follow the Bosch process, the second step of the Bosch process, that is the passing it through the more excess of steam, which leads to the formation of CO2 and H2, and moreover you need to remember the catalyst and the catalytic promoter as well, right? So this is how the different methods by which we can prepare the hydrogen in the industries. So they include all the industrial methods, right? So we'll be discussing more about it. That is the other kind. There are actually many kinds of method by which the hydrogen can be obtained, but the few methods, the important methods which are actually used by which the hydrogen is obtained, we have just discussed so far, right? So before we do further, we should know, before we study the chemical properties or more about it, we should know actually what the hydrogen gas is. What are the properties, physical properties which are associated with the hydrogen gas? So they are, it is, do it has some odor? No, it is odorless. It is tasteless. It is non-poisonous. And the most important thing about the hydrogen is less dense. It is, or you can say it is lighter than air even. And how many times? By 14.4 times it is lighter than air. And it is the, you can say, the reason that why the hydrogen is used in the meteorological balloons, right? So you need to remember, this is a very important property of hydrogen, that it is very dense, or you can say it is lighter than air even. And how many times? 14.4 times lighter than air. So you can feel that how light it is, right? And so does it catch fire? Yes, it catches fire. It is combustible gas. We'll be discussing these points further in detail as well, because these properties serve as an, you can say, important, they just play an important role. That is why hydrogen is used in many other fields, right? So it is a combustible gas. It is slightly soluble in water, not so soluble in water. Slightly soluble in water. And if we talk about its, you can say the that whether it support combustion or not, so it is non-supporter of combustion. And what about pH? It is neutral to pH, neither acidic nor basic. So these are the physical properties which I have summed up for you. Again, I am repeating, it do not have any odor, no taste, and even it is non-poisonous, and moreover it is colorless gas too. So you need to remember, it is odorless, it is colorless, it is tasteless, and it is non-poisonous gas, right? And the most important property that I told you, that it is lighter than air. And how many times? 14.4 times lighter than air. And due to this reason it is used in the meteorological balloons, because it is less dense, and even it is so lighter than air that it helps in meteorological balloons to perform their function. Right, and it is combustible. It burns in oxygen, in supply of oxygen. And one more important thing that is coming in my mind, which I want to share it with you, that you must have heard that the gas which burns with the popping sound. So you know that it is a hydrogen gas. Yes, you are right in that case. The gas which burns with the popping sound is hydrogen gas. But not always the hydrogen is going to burn with the popping sound. This is the important thing. So like most of you just randomly say yes, popping sound, yes, it is hydrogen. But every time the hydrogen is not going to produce the popping sound. It is going to produce the popping sound when the hydrogen contains some amount of air in it, right? But if it is pure hydrogen, it is not going to produce any kind of sound. Only it will produce a pale blue flame, that's it. Right, so you need to remember that, and I think you got it in the right manner what I said, that whenever the hydrogen burns, yes, it produces a popping sound, but only when it is present with air, or you can say some amount of air is present with the hydrogen, or you can say hydrogen air mixture is present, right? But when pure hydrogen is present, no such sound is produced, no popping sound, no nothing is produced. It just burns smoothly with no sound, but the flame is pale blue flame. This is very important, and you should know that, right? And what about the water? Yes, it dissolves in water, but in a very you can say a small amount. It is not so soluble in water. And non-supporter of combustion, it gets burned, but it is non-supporter of combustion. And what about the pH? When you test it with the pH, it neither turns red litmus blue, nor it turns the blue litmus red, or you can say the pH, on pH scale the value is just 7. That means, that indicates it is a neutral gas. So these are the properties which make it different from other elements, and you need to remember these properties, because due to these properties it is serving as a main constituent of many compounds, or it is serving many uses as well, right? So next we are taking up is about hydrogen. We are just starting with the new topic, that is how we can test the hydrogen. Suppose I give you some sample, I just give you some sample, and I just ask you that tell me that whether the sample I gave you is of hydrogen or not. So what are the specific tests which are striking in your mind that you can perform? Just think of it. I'm repeating the question. I'm giving you some sample and I'm asking you that just prove it to me that it is the given sample which I gave you is of hydrogen. So how you're going to predict it that the sample is of hydrogen or not? So the first thing with what you will be doing is, because whenever we get certain kind of sample, the one thing we just see the physical appearance of it, or anything which can be just sensed by the physical senses, right? So what if the gas appear to be odorless, colorless and tasteless? So that means it is going to be hydrogen gas. So this is the first test which we can feel by the senses, right? But only you can say on the behalf of physical senses, we cannot say that with the confidence that yes, it is a hydrogen gas. We need to perform certain kind of test as well. So what test I am performing is that I will just burn the hydrogen, and the pure hydrogen is going to burn with the pale blue flame forming H2O, right? And if in case it is not pure, because we can get the pure hydrogen as well and we can get the impure sample as well. We are not aware that the sample which we are getting is a pure or impure, right? So we have to perform the different experiments as well. So if it is an impure hydrogen, what will happen? If we'll burn in oxygen, obviously it is going to produce an H2O and it is an exothermic reaction, but the gas which will be produced will burn with the popping sound. I think you are familiar with the magic pops which the children eat, right? So that what happens when you keep that pops on your tongue, it just do the pop sounds, right? So similarly, when the hydrogen gas burns, it produces the same kind of sound, that is the popping sound, the pop sound you can say. So that means if you have a sample and somebody asks you that prove it is in hydrogen or not, so what you are going to do is you are just going to perform, and first you will see it, that how it appears, right? And if you have certain idea that yes, it can be in hydrogen, just burn it. So if it is pure hydrogen, it will burn, but there will be no sound. So don't think like that the hydrogen always produce the popping sound. It may not produce, because the pure hydrogen do not produce any kind of sound. It just burns with the pale blue flame, right? And if it is impure hydrogen, then the popping sound is just on the tips. You know that the popping sound is the characteristic property of the hydrogen, right? So this is how you are going to just perform